All right, let me grab our first part of our page here. So our first part is all about parallelograms. Oops, I didn't do a very good job. There we go. So again, what we're doing here is if we start out with, on these first ones, we're going to start out with a quadrilateral. So on all of these, we're starting, all we know is that we have some quadrilateral. If we know some additional information, we'll be able to figure out that that quadrilateral is a parallelogram. So that's what these first three are all about. So the first one, if two pairs of opposite sides of a quadrilateral, so we're starting out with a quadrilateral, two pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. And if we mark our figure, so if we had a quadrilateral and it was marked like this, that would guarantee us that our quadrilateral was a parallelogram. A couple of other ways that it could be shown is we could say that, just that we would write it out. It might be written out. If AB is congruent to DC and AC is congruent to segment BD. That's just another way of writing this out. We could say, rather than congruent, we could talk about their lengths. AB equals DC. And AC equals BD. So in the first one, we're saying the segments are congruent. In the second one, we're saying that their lengths are the same, which is essentially the same thing. So our figure could be marked like this. It could be written out like so. If we know that two pairs of opposite sides of a quadrilateral are congruent, that guarantees that we have a parallelogram. Questions on that one? Yes.
So what do we only use this on the final?
On the final, the graphic organizer will be like the one that we're going to use on the test. So it'll be a quadrilateral graphic organizer and a parallel line graphic organizer.
So not this?
Not this.
Okay.
If our second one, if one pair of opposite sides of a quadrilateral, so we're starting with a quadrilateral, if one pair is parallel and congruent, then the quadrilateral is a parallelogram. So the way that would be marked is, we'll pick this pair. So the hash marks, the tick marks tell us that they're congruent, and the arrows tell us that they're parallel. So our figure could be marked like this. We could say that segment AC is congruent to segment BD, and segment AC is parallel to segment BD. That's the way we would write it out. And it could be the other pair of sides. You just need one pair that is parallel and congruent. So again, we start with a quadrilateral. We know that one pair of opposite sides is parallel and congruent. That guarantees that we have a parallelogram. Questions on that one? All right, the last one here. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Now what does bisect mean? Cut in half. So if you need a reminder, bisect means cut in half. So let's draw in our diagonals. I'll make them red here. And I'm going to put a point in here. Let's call this point E. So that point is point E. So several ways that we could show this on our figure or if it was written out. Our diagonals could be marked like this. So E is right in the middle of both sets of diagonals. If we wrote it out in words, we could say it several ways. We could say E is the midpoint of AD, segment AD, and segment BC. So E is right in the middle. We could say that the diagonals bisect each other. AD and BC bisect each other. That's what this says up here on top. We could say, if we wrote out what we marked here, AE, segment AE, is congruent to segment ED. And segment BE is congruent to segment EC. So all of these are ways of saying the same thing, that the diagonals bisect each other. The diagonals bisect each other, that guarantees us that we have a parallelogram. Questions on that one? So on these first three, we're starting with a quadrilateral. That's all we know is we have a quadrilateral, and then these other things will guarantee us that that quadrilateral is a parallelogram. All right, let's look at the next ones. The next ones have to do with rectangles. So on these two, we're starting with a parallelogram. So we know we have a parallelogram to start with. And these are things that we can figure out about this parallelogram that guarantee us we have a rectangle. So the first one, if one angle of a parallelogram, we're starting with a parallelogram, is a right angle, then the parallelogram is a rectangle. What is a right angle again? How many degrees? 90. So if you need a reminder, write in that that's 90 degrees. Now my picture here shows, just to re-emphasize, don't go by what the picture looks like, go by what the information tells you. So the way this figure would be marked, I could mark that, we'll pick angle A here. If I mark this with a little square, that tells me it's a right angle, no matter what it looks like. I could say the measure of angle A is 90 degrees. I could say angle A is a right angle. I could say that segment AB is perpendicular to segment AC. This little upside down T means perpendicular, means they make a 90-degree angle. All of these things tell us that this angle has measures 90 degrees. So these are all the same way of saying the same thing. So if we have a parallelogram, if one angle is a right angle, a 90-degree angle, that guarantees us that that parallelogram is a rectangle. Questions on that one? All right, the next one is called the Housebuilder Theorem. It says if the diagonals of a parallelogram, so we're starting with a parallelogram, the diagonals are congruent, that guarantees us that the parallelogram is a rectangle. So let's draw in the diagonals. Now the reason they call it the Housebuilder Theorem is that people have been using this idea for a long time. Archaeologists have found evidence that ancient people use this idea of congruent diagonals to make sure that the bases of their buildings, the foundations of their buildings were rectangles. So they'd measure out their foundation and make sure that the diagonals were congruent to make sure that they were starting off with a rectangle. So that's why we call it the Housebuilder Theorem. So if the diagonals are congruent, then the parallelogram is a rectangle. So it's kind of hard to make the tick marks on the diagonals here, so we'll just write it out in symbols. We would say that AD is congruent to BC. We could also say AD equals BC. So all of these are different ways of saying that the diagonals are congruent. And that guarantees us that our parallelogram is a rectangle. Questions on that one? All right, let's look at the last one. The last set is all about rhombuses. So again, on this one, we are starting out with a parallelogram, and we want to know what we have to know about the parallelogram to be guaranteed that we have now a rhombus. So for the first one, if one pair of adjacent sides is congruent, then the parallelogram is a rhombus. And who can tell us, who remembers, what does adjacent mean? Next to. Adjacent means next to. So if you need a reminder, so adjacent means next to. So we're saying if one pair of sides that are next to each other in a parallelogram are congruent, then the parallelogram is a rhombus. So if we mark this picture, it would look like this. These two sides are next to each other. They're congruent. That guarantees us that our parallelogram is a rhombus. If we wrote it out, we'd say AB is congruent to AC. Another way we could say it is the length of AB is congruent to the length of AC. And we could use any two sides. It doesn't have to be just these two sides. Any two sides that are next to each other on a parallelogram, if they turn out to be congruent, then that parallelogram is a rhombus. Questions on that one? All right, the next one. If the diagonals of a parallelogram bisect the angles of the parallelogram, then the parallelogram is a rhombus. And again, what did we say bisect means? Cut in half. So let's draw in our diagonals, and we'll show that the diagonals on our picture, that they cut the angles in half. So this one we end up with a lot of marks on this one. So there are diagonals. We're saying that they cut the angles in half. So we're saying those two angles are congruent. And we'd be saying that these two angles were congruent. And those two angles are congruent. And finally, that these two angles, I have 4 tick marks there, those two angles are congruent. So each set of angles in the parallelogram is cut in half. If we were to write that in symbols, we'd say that we could say that AD, segment AD, bisects angle A. We could say the same thing for the other diagonal. Segment BC bisects angle C. So this is just one of the angles. We're saying it bisects one of the angles. We would be saying that the diagonals bisect all the angles. I'm not going to write all 4 of those out. But segment AD bisects angle A. Segment AD bisects angle D. Segment BC bisects angle B, bisects angle C. We could say, we can pair our angles up. We could say that angle BAD is congruent to angle CAD. So that's saying these two angles are congruent. Angle ACB is congruent, ACB is this one, is congruent to angle DCB. That's saying those two are congruent. This angle's been bisected. And I can do that for all of the angles. I would be able to do that for all of the angles in the parallelogram. So these are different ways of saying that the diagonals bisect the angles. The angles are congruent. We can actually write out that they bisect the angles, or we can say that the angles, each of these angles is congruent in pairs. So I haven't written out everything, I've just written a few examples here. Questions on that one? All right, our last one. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And perpendicular means what kind of angle? Right angle, or how many degrees? 90 degrees. Perpendicular, right angle, 90 degrees, all mean the same thing. So if the diagonals are perpendicular, then the parallelogram is a rhombus. So if I draw my diagonals in here, if I drew on my diagram, even though it doesn't look that way, if I drew this little square for a 90-degree angle, that would tell me that those are perpendicular, even though they don't look like it. If I call this point E here in the middle, again, if I said the measure of angle AEC is 90 degrees. That would be a way of saying that the diagonals are perpendicular. I could say segment AD is perpendicular to segment BC. This upside down T means perpendicular. That's another way of saying we have a 90-degree angle. They're perpendicular. What would be another way? AD is perpendicular. Measure the angle is 90 degrees. I could say that angle AEC is a right angle. So all of those are ways of saying that the diagonals are perpendicular. And that guarantees us that our parallelogram is a rhombus. Questions on that one? All right, so we had three ways to show that a quadrilateral was a parallelogram. We had two ways to show a parallelogram was a rhombus, and three ways to show that a parallelogram is, did I say rectangle? Two ways to show that a parallelogram is a rectangle. Three ways to show that a parallelogram is a rhombus. The homework today is all just using this information to decide something about shapes that you're given. So it's just using what we just learned to figure out things about shapes and maybe solve problems about shapes. So that's all I was going to do with this graphic organizer.